You're listening to a podcast from 702 and Cape Talk.
9 minutes after 10. This is a Friday, and of course, you know what happens in the second hour every week. Unless there's special breaking news, we are enthralled by the knowledge of one Chris, the Naked Scientist.
702 and Cape Talk.
The Naked Scientist.
Hello, Chris. How are you?
Hey, good morning. I'm good.
Oh, I thought you were fluey. Was that just a rumour?
No, well, I had some, virus, horrible blinking thing. So that's why I sound kind of stuffed up. So I'm sorry about that. No, I feel all right. I'm coming out the other side now.
Yeah.
I don't often get ill, actually, but I think that the respiratory viruses that are around this season, certainly here, have been much more intense than usual. I think we're in a bad year because they do that. You get different variants because these things mutate and change and wax and wane, and that's driven by the population's immunity as well as evolution of these viruses. And sometimes you get a real doozer of a virus emerges. And I think this year we're having
I'm
a
sorry
bad
to
year.
hear that. I hope you will feel sufficiently lucid for the next 20 minutes. If you've just tuned in, of course, you can give us a call and put a question that you might have to Chris. This is a very popular segment, so you better do so quite quickly on 011 883 0702. And Cape Townians, you can ask the Naked Scientist a question by dialing the number 021 446 0567. Feel free to also SMS your questions. We'll check those on 31702 or 31567. And you're more than welcome to tweet a question for Chris. I'll also check Twitter regularly and put some questions to him. I get as excited about his answers as I do about your questions. Sometimes they're really beautiful and interesting. But before we get there, Chris, there's an interesting story about 7 Earth-sized planets that have been spotted.
Well, this has made enormous news around the world this week, and it was a paper in Nature by researchers in Belgium, and the observations they've been making have gone on over a number of years, and they involve originally a robotic telescope called TRAPPIST-1, and subsequently the NASA Spitzer Space Telescope. And they've been looking at this star, TRAPPIST-1, which is named after that telescope that first looked at it. And it's an interesting star because it's very, very small. It's a star that's about the size of, or just a bit bigger than our own planet Jupiter. And this means it's actually very cool and dim, but warm nonetheless. And this makes it much easier to observe because normally stars are so bright that seeing anything around a star orbiting like a planet is really tricky because the starlight dazzles you and you cannot see the little planets. But a much dimmer body like this one has made it possible for this group of scientists to see that there are in fact 7 planets. They are roughly the same sort of scale as the Earth and our clutch of planets, rocky worlds in the inner solar system. And because of the fact they are orbiting in very, very close to this very small, dim star, they're nonetheless warm because we can work out what the temperatures based on the radiation that's coming off of that star, the thermal radiation coming off that star will be. We can work out roughly what the surface temperatures of those planets are likely to be, and we can also work out how big those planets are and how much they weigh, so we can work out what they're made of. And this suggests that they're all orbiting in what could be dubbed the habitable zone, or the Goldilocks zone, which is where the combination of the size of the planet, its proximity to the star, the thermal output from the star, when you factor all those things in together, does that translate into a surface temperature of the planets which is compatible with the existence of liquid water? That does appear to be fulfilled here. So researchers are pretty excited because this is effectively in our cosmic backyard. It's just a mere 40 light years away. And you think, oh, that's just around the corner. Actually, it's still a very long way because remember that light travels at 300,000 kilometres per second. So with the best rockets we've got, it would take an extraordinarily long time to get to this clutch of planets. But it's still very exciting because, the thing is that we can make very careful observations of these worlds because the starlight is dim, which makes seeing them much, much simpler. And with better instruments that are now coming along in the pipeline, we'll be able to interrogate these planets at much higher levels, including even seeing what's in their atmosphere and looking for signatures, chemical signatures that might tell us a bit more about the conditions on them. And that's all coming. Very exciting.
Fascinating. Chris, let's take our first question today from Twitter. Here's one from Mullen. Mullen says, Eusebius, please ask Chris, why is it that a toothache is more likely to happen at night than during the day? I don't know if that's true.
I don't think there's any. I don't think there's any evidence that it's more likely to happen at night than during the day, because what is a toothache? Well, a toothache is irritation of the nerve which supplies the innards of the teeth. The dental nerves, for instance, that come through on the lower jaw, they send little sprays of nerve endings up into the teeth, and these are important because they inform the nervous system, for instance, how hard you're biting down on things, and that's important so that you can control chewing movements. They also use that information to trigger salivation and things like that. And, of course, sensation is very important, because if you injure a tooth, you need to know about it. And when you get damage or breakdown of the material that makes the tooth, the enamel, and then the much softer dentine inside, you get inflammation and then chemical irritation of nerve endings. That's usually the consequence of bacteria getting in there and eating sugars in your diet and turning them into acids, and the acids erode the teeth. There's no reason why that would happen more during the day or during the night. It's more likely you'll notice it more at night, because you would normally be asleep and it will wake you up if it's very uncomfortable, or it may even stop you going to sleep. So you're going to notice it, and that might be why this individual is saying, well, I get this at night. But it'll happen any time. And when it happens, it's painful for people, and they need to go and see the dentist.
Absolutely. Anne,
So clean
good
your teeth
morning.
properly.
Thanks so much for calling in.
Good morning to you, Chris. I hope your flu gets better.
I
Two
am.
quick questions. Once you finished a course of chemotherapy, right, how long? I was told it'll take anything from a month to 2 months to wear out of your body, right? I mean, I must say, nothing affected me. I didn't lose a lot of hair. I never got nauseous or anything like that. You know, I lost a lot of weight. And I thought to myself, now, how long is this? Because I still get lightheadedness, you know what I mean? And a little bit dizzy at times. And I think, Anne, just take your time, you know what I mean? Don't rush. And then also, I said to them, don't I lack iron? And they said, no, you think you lack iron, but it's a chemo that you think. So those two quick questions.
Well, the answer is that when we say
And I listen on the radio.
chemotherapy, chemotherapy is a terminology that just means giving chemicals to somebody which have a therapeutic effect. So it's an overarching term that describes many, many different molecules, and many of these different molecules work in many different ways. So there is no one-size-fits-all answer to this. There are some drugs which you give them today, they will be gone from your body tomorrow. There are other drugs that have a very long, what we call half-life. In other words, the time it takes for the concentration of the drug in the body to fall by 50% can be days, weeks, months, in some cases years. So there's no simple answer to this. The most chemotherapy agents, which are for cancers, they target rapidly dividing cells, because one of the consistent features of aggressive cancers is that the cells are growing very fast. So if you make chemicals that hit cells that are growing very fast, that's one way to hit the cancer harder than your own healthy tissue. So therefore, you tend to make drugs which have a short duration of action in the body, because you don't want them having a very prolonged action, because once they've done damage against the cancer, then they would shift their focus onto the healthy tissue that's left behind if they hung around for a long time. So most of these agents have a short half-life in the body. But then there's the other thing to consider, is that once you've done damage to the cancer, there will be some damage to the healthy tissue as well, and it does take time for your body to recover. It's a bit like if you cut your skin, you get a graze. It doesn't instantly heal up overnight and then it's all gone the next day. There's a slow healing process where the tissue repairs itself and then it remodels itself, and then the scab falls off and you stop itching it and scratching it, and then eventually everything looks normal again. But it takes time. And as you get older, the pool of stem cells, which are there to replace the tissues that we damage and wear out during the day, that pool is a diminishing pool. So you've got fewer resources to invest in repair. So healing does take longer as you get older. And so you need to be patient.
Okay, I'll do that because I am pretty old. Yeah.
Well, there we are. But fit enough to phone the radio show, which is really good. Congratulations.
Okay, thanks. And what about the iron levels? Does the chemo got anything to do with the iron levels in your body?
Well, it can do. Not necessarily just iron, but chemotherapy poisons different tissues in different ways, and therefore it can have lots of effects on your biochemistry, which is why when doctors are giving people chemotherapy, they keep an eye on lots of things, including blood cell levels and liver enzyme levels and how well your kidneys are doing. And they will then adjust other treatments to compensate to keep you healthy. So that's something that the doctor will be monitoring, I'm sure.
Thank you, Anne. Thanks so much for calling in. Much appreciated. Take another one from Twitter. Sandile wants to know from you, Chris, what causes hiccups?
Well, the fancy medical word for hiccup is a singultus. So if you go to the doctor and complain that you're suffering from, chronic singultus, then you've got chronic hiccups. And the longest attack of hiccups, I think, in the Guinness Book of Records was about 70 years. It's a neurological reflex in the same way that coughing is a reflex, blinking is a reflex, and your knee jerk is a reflex. We don't know exactly why it happens, but what we can say is that you have this phrenic nerve, which is the nerve that supplies your diaphragm and makes you breathe, comes out of your brain stem and is controlled by the respiratory system in your brainstem. So you have these collections of nerve cells that send signals down your phrenic nerve and tell you to breathe. For some reason, and in response to various stimuli, it then gets into this pattern where it sends bursts of activity down your phrenic nerve and makes you have sudden involuntary indrawings of breath, which is the hiccup noise. And it seems to be associated with excitement. So people, when they're anticipating something, tend to get this. Also, certain drugs can do this, and I think in the case of the person who was in the Guinness Book of Records, I think brain injury can do this as well. So if you damage parts of the nervous system, sometimes this can trigger hiccuping attacks. But drugs is a common one, and people often say it's a side effect of drugs, and some people say it can be a side effect of eating chili. Some people say they have a spicy food or a spicy curry or something, and then they develop a bout of hiccups afterwards. I luckily don't get that, and I do love curry.
Let's go to Pretoria. Mike, good morning. Thanks so much for calling in. What is your question for Chris?
Hi, good morning. How are you?
Hi, Mike.
Hi, this is Mike from Pretoria. My question is, what is the role of this vast amount of oil in the earth? And what are the implications as we're using oil or we're taking oil from the earth as we do? Why is oil there?
Okay, well, the oil which is in the Earth's crust is there because millions of years ago there were lots of dead creatures that that sank to the seabed, and then thanks to geology intervening, something opened up a gap in the bottom of the ocean and helped all this stuff to get inside the surface of the Earth. And because these creatures had fat in their bodies, all our bodies are full of fats around our cells and so on, if you get the right geological situation where you get a source of carbon in the form of the fat in the bodies of these dead sea creatures, and you've got a way of stewing all this stuff down at the right sort of temperature, because the deeper into the earth you go, the higher the temperature is. You need to get to about 100 degrees or so, and you need to also enclose this material in some kind of geological formation so it then can't escape. Over millions of years, the combination of being trapped at a high temperature, 100 degrees or so, with the rock overlaying it being impervious so that the stuff can't get out again, you trap all this material and you facilitate chemical reactions happening that cause the fats and materials in the bodies of those animals to convert into crude oil. And it then sits there for millions of years until we come along and we drill a hole through the impervious layer of rock which is trapping the oil, and we extract it. And there are various places where the geology is perfect around the world historically to have made this happen. The Middle East is one of them. Off the coast of Scotland in the North Sea around England is another example. Down the west coast of Africa is another example. So there are lots of places. And lots of people think, well, is this oil, if we take it all out, are we going to leave a massive hole in the Earth's surface? And what happens to that? The answer is actually that there aren't these enormous holes in the Earth's surface where the oil is at the moment. The rock that's in the ground is porous, so it is rock that looks a bit like sponge. So there are lots of holes in the rock, and those holes are all in continuity, and they're all stuffed with oil. And when you draw the oil out, then all you're doing is replacing the oil that was in there with something else, like water, which pushes or displaces the oil out. So you're not leaving a cavity underground, but equally, there isn't a giant cavity underground in the first place. There's a piece of sponge which has got oil in the holes.
Absolutely. 23 minutes after 10. If you want to squeeze in your question, we've got about 5-6 more minutes. 011 883 0702. That's the number where you can reach us if you're in Johannesburg, and in Cape Town, 021 446 0567. In fact, let's take a bit of a breather, Sham, so that Chris can just catch his breath a little bit. Yeah, Bandile tweets, Eusebius, your guest is giving me a lot of inner peace. It can be useful to be a nerd that just knows a lot of random facts. Absolutely. And you're a nerd yourself, Bandile. Own that stuff. 24 minutes after 10.
702 and Cape Talk.
The Naked Scientist.
Let's go back to the line, squeeze in a couple of more calls. In Belleville, we've got Wilhelm.
Good morning, Eusebius and Chris. I'm quite fascinated by the Big Bang. I just want to know, I think I've heard before that nobody really knows what happened before the Big Bang. But at the Big Bang, when it happened, was it gas that exploded? Was it matter? And what's the scientific explanation? How did the spark, or how did that explode? And was it like in the middle of the space, or was it in a corner, or I'm trying to visualize it.
Thank you, Wilhelm. Delicious question. Chris?
Yeah, good luck with that. That's keeping a lot of cosmologists and very bright-minded people busy. We don't know is the simple answer to this. It happened about 13.8 billion years ago. That we do know. How do we know that? Well, we know how fast space is expanding, and there are signatures written into radiation left over, what we call the afterglow of the Big Bang, and those signatures give us a clue as to when all this happened. And we've got some pretty accurate measurements now. There were various telescopes, including the Planck telescope, Planck mission, which went up a few years ago and has made lots of observations, which is helping us. But we really don't know. What we do know is that about 13.8 billion years ago, there was this moment of creation when some kind of energy source unleash this energy, and because, as Einstein told us, E equals mc squared, energy and mass are interchangeable, and therefore this release of energy was subsequently converted into material, matter, and that matter has coalesced since as the universe has expanded and cooled into stable elements. Initially, the vast bulk of it, maybe 90% of it, was hydrogen, and there was a bit of helium made and then a tiny trace of lithium made. Those three elements were the products of the Big Bang. Most of that hydrogen then coalesces into stars, and those first enormous stars burn, fuse hydrogen, and nuclear fusion is the way in which you add simple small elements together to make bigger ones. And slowly, over the evolution of the universe, over millions to billions of years, those small elements have been fused in stars to make bigger elements, and so all of the complicated chemicals that are in your body, the nitrogen, the oxygen, the carbon, the phosphorus, the sulfur, they have all come from nuclear reactions inside stars and in the death throes of stars, when stars have blown themselves to pieces and then expelled and spewed their innards out into the universe more widely, and then they've come together again in another system somewhere, and eventually some of them made you. So it's interesting to think you're all made from dead stars. But how that process got started in the first place, we haven't the foggiest, but we're trying to find out.
Bandile wants to know whether it's possible to create rain artificially, Chris. He says that he's heard that the Chinese have rockets that fire a certain chemical in the air.
This is perfectly doable, and it's not just the Chinese. Other people have been experimenting with this for a long time, but the Chinese definitely did do this around the time of the Olympics. They wanted perfect weather for the Beijing Olympics and the opening ceremony in particular, and so they fired, I think they used silver iodide. And the mechanism of doing this, if you fire particles that are small and attract water into the atmosphere, you can trigger a process called nucleation. And when you have water vapour, which are water molecules just diffusely distributed in the sky, if you give them a surface to cling to, then it draws the particles together and they begin to attract other particles, and then they condense, forming droplets of water. And it might sound paradoxical that to get rid of rain, you make it rain, but that's exactly what you do. So you seed the formation of clouds and rainfall somewhere else, and then by the time the air that you've robbed all the water from moves to where you don't want the rain, it's of course much drier, there are no clouds then, and you have nice weather. And this is eminently doable, and it's via this process of nucleation.
Chris, thank you for your knowledge, sharing it, and your lucid explanations. Get well. We'll do it again next week.
I'm looking forward to it. Thank you, Eusebius. Thanks, everyone, and see you soon.